All right, we are here. We are going to be working on Notes Chapter 3, Motion Terms and Definitions here. Okay, it has two tables on it. We're going to be looking at the first table here first and just kind of working through this with these definitions. Okay, so you just follow along with your notes and we'll work through these definitions. Okay, so we're going to start off with these first two definitions. These are called quantities here. Okay, quantities. Okay, they're types of quantities. Okay, so we have what's called a scalar quantity and what's called a vector quantity. They don't really have symbols or units. They just kind of describe how different quantities are. So with the scalar quantity, scalar means it's a quantity with no direction. Okay, it's a quantity with no direction. So when I say quantity, what I'm talking about is that it's a number. It has a magnitude, okay, but it has no direction on it. Some examples would be time. Okay, if you think about time, it's a number with no direction. We don't want to say like 5 seconds back or 5 seconds to the right. That doesn't make any sense. Temperature is another example of a scalar quantity with no direction there. Okay, 25 degrees Celsius to the left doesn't make sense. Speed is also another scalar quantity. Okay, if you think about it in your car, you have a speedometer which measures speed, and your speedometer in your car will not tell you what direction you traveled or are traveling. It'll just tell you that you're going 30 miles an hour. It will not tell you that you are going 35 miles an hour north. Okay, so all these quantities are called scalar quantities here. Vector quantity is very similar to a scalar quantity, so it's a quantity, which means it has a number. But as you might have guessed, it's a quantity with a direction added to it. So they always have direction. Vector quantities always have directions. Some examples are position. I could say that I'm 25 meters east of the tree, or right now I'm about 5 meters west of the door. So you need to have that direction on there when you define a position. So it's a number, quantity, and a direction. So it could be either northeast, southwest. It could be any angle away. Okay, so a direction with that. Displacement, we'll talk about what that is here in a second. Is vector. So a displacement and a velocity, which is also similar to speed, but it has, you guess it, a direction. So these are all examples of vector quantities. Alright, I'm going to be changing some things around on here. We usually have the same symbol here for distance and position. We usually have the same symbol, so what I'm going to do, I try to change it, but what I think I'm going to do is I'm going to change distance to the symbol x. Let me change that here. So that's x, and then we're going to change position to d, little d. I'll explain why that is, and you'll see. It should make a little sense. So this is what we'll be using for this. So these are different types of measurements here. So distance is a scalar quantity, so we know that it's a quantity with no direction. Okay. The symbol we use, these are also called a variable. I'll just put VAR, variable. These are what we'll put in the equations. We'll put x, a d, and a delta or triangle d here for these different measurements. So distance, we'll use x. The unit we put after the number, and we usually abbreviate the unit. So the unit for distance we use SI units, so standard units, is the meter, and we'll use the symbol little m for that. So if it's like 20 meters, we'll write it as 20 m. One thing to note is try not to get the symbol or the variable mixed up with the unit, because they are both single letters. They're generally smaller case, and they're easy to get mixed up. Remember, these go in the equations, these go after the number. Okay. So distance, all distances is total path traveled. Total path traveled. So in your car, your odometer measures how far your car has traveled. Okay, it doesn't tell you where it's traveled, so it just says your car has traveled 100,000 miles, but it doesn't tell you in what direction. Another example I like to use for distance here is if you run track. Okay, so I'm going to draw a track right here. This is a standard 400 meter track, and you run one time around it. Okay, so you run one time around the track. That means your distance, your x distance that you've traveled, is 400 meters. Okay, because you've traveled 400 meters. But if you think about it, you start and end up in the same spot. Okay, so this kind of ties in with these next two concepts here. Position, I know that distance starts with a d, and we'll use an x for that, but position we use d, and this will make sense when we talk about displacement. Okay, so position, we're going to use the variable little d on that. See that? Okay, and the unit is meter again, so these are all, I have units of meters, a little m. Okay, and position, it's vector, so we're going to be adding we're going to have to add a direction to this. So this is a location relative to the origin. Okay, so location relative okay, and I'll talk about this more on Tuesday when I'm back in class, but you get to define what your origin is. The origin is just where the x and the y coordinates cross. Okay, it's 0, 0 on a coordinate system, and you can define where that's at. We usually just choose like an object. Like, so if I say my position is 5 meters west of the door, when I say that, I'm making the door my origin. I'm stating my position, my distance and direction relative, okay, to the origin that I chose, the door. Okay, so again, it's a quantity and a direction. So a position is always some distance plus a direction. 5 meters east, 25 meters southwest, and so forth. Displacement is similar to distance, so these are kind of related. Distance and displacement are related to each other. Yeah, they're related. They're almost the same, a little different because distance is a scalar, whereas displacement is a vector. Okay. Notice this little triangle shape right there. That is the Greek letter delta, and what we're going to use for that is it'll be a stand-in for the words change in. That's what delta means. So you read this, you can say change in d. Well, what's d? D is a position. So displacement, this is why I changed that to little d. Displacement ends up being a change in position. Okay, and that's actually the definition of it. It's a change in position. Okay, between any 2 points. So change in position. So this one has an equation. We'll put a nice big square on this rectangle. So displacement is equal to, and a change in position, guys, just remember, we're going to be seeing this throughout the entire year, is final minus initial. The final position minus the initial position. That's what this delta triangle change in means. So here we're going to have a final position minus an initial position, and this is your first formula. This is the formula for displacement. Displacement is change in position. Final minus initial. So if you think about it, going back to this track example, you're running on the track. Your change in position, it doesn't matter where my origin is at. If I start here, that's my initial, and I end there, that's my final. They're the same position. Any number that is the same and you subtract from each other equals what? 0. So that's where you can really see the difference between distance and displacement, is when you move around in a circle, or if you end where you start. Okay, you do travel a distance, but if you end where you start, your displacement is 0.